I've got a problem up here for you to try. Again, because these problems are rather long, I'm trying to do double duty here. So I've selected a problem that's assigned from the homework so that doing this problem as part of the lecture video is actually getting a jump start on the homework as well. So it's number 71 from the homework. H of x is 2x minus 4 over x plus 3. And I want you to graph it, including the intercepts, holes if there are any, and asymptotes. Again, doesn't need to be perfectly to scale, but should be positive and negative on the appropriate intervals. Okay. On this one, I did not ask you to check for symmetry. You can if you want to. And I didn't ask you if there's a horizontal asymptote to see if you touch or cross that asymptote. So those are steps that the book includes in its 8-step process that I've said if I want you to do those, I will explicitly include those in the directions. You don't need to do those for this problem, although you certainly could if you wanted to. Okay, so pause the video, give that a shot, and then we'll check it together. All right, so I've got h of x is 2x minus 4 over x plus 3. Now, if I wanted to, I could factor out a 2 on the top, but that's fully factored as far as the x's goes. I'm not going to be able to break things up because each of these is just a linear function. Okay, so I think I'm going to just keep that as is. Let's see. I like to start with the values that are not in the domain. And I can see negative 3 would make the denominator 0. We can't have that. Okay. Now, negative 3 does not make the top 0. That tells me that we're going to have a vertical asymptote at negative 3. Okay. There won't be any holes because that's the only number that doesn't make the denominator, that makes the denominator 0, and it doesn't also make the numerator 0. Again, this was already in lowest terms. I'm only going to have a hole if I'm able to reduce the fraction because of the same factor made both the top and bottom 0, and I can cancel that. Okay, excellent. So let's take a look at intercepts. If I look for the y-intercept, I'd be plugging in 0 for h, 0 to h, plugging in 0 for x. That's going to give me negative 4 over 3. Notice it just kills off the x's. Okay, so my y-intercept is the point 0, negative 4/3. For x-intercepts, h of x would equal 0 if 2x minus 4 equals 0, provided that x isn't negative 3. The top is 0 and the bottom isn't. Now, I've already confirmed that the top and bottom are never simultaneously 0. I do like to just write this because if I get in the habit of just saying it's 0 if the top is 0, and then later I have a problem where the top and bottom are simultaneously 0, I might forget that that doesn't count. So I'm usually going to write that down just as a reminder. Notice this would mean 2x equals 4, so that x equals 2. So my x-intercept is the point 2, 0. All right, excellent. Let's actually clean up the scale a little bit. There we go. Okay, now I didn't ask you to check for symmetry on this one, but if I had, at this point you can say there's no symmetry by inspection. This point does not have a mirror image. This asymptote does not have a mirror image. And because this is on the x-axis, its mirror image around the origin would be the same as its mirror image across the y-axis. If I turned it upside down, that point would move to this point as well. Okay. So, let's see, we've got our vertical asymptote, we've got our intercepts. Let's check the end behavior. So I know that as x goes to infinity or x goes to negative infinity, and again, another way of saying that is just that the absolute value is going off to infinity, h of x is going to behave approximately like the fraction of its lead terms. The lead term on top is 2x, the lead term on bottom is x. Now, I can cancel that x and say that's going to give me 2. Now, if I were working with this as a function and concerned with its domain, I'd want to record that x can't be 0, but I've indicated that I'm looking at what happens when x is really, really big. So I've already ruled out the possibility of it being 0. This just tells me we get a horizontal asymptote at height 2. Okay, excellent. So I think we're ready to play connect the dots. Now it's often a good idea to just scan through the directions to make sure you haven't missed any important points. So did I get my intercepts? Yes. There weren't any holes, I checked. Got my asymptotes, one vertical, one horizontal. Okay, so I just need to make sure I'm positive and negative on the appropriate intervals. I like to have a number line drawn. It's not absolutely necessary. I'm going to mark off the places where my function could change sign. That's the location of the vertical asymptote, because if my function is undefined at this point, it's possible that it's negative on one side and positive on the other side of that asymptote. And then at 2. Okay. So x-intercepts and vertical asymptotes. The only other thing I'd include here is if I happen to have a hole and it was on the x-axis, so it was like the lack of a point but on the x-axis, I'd include that location too. Okay, so to the left of -3, now I don't have any points, but I can actually tell just by looking at that it's got to be positive. That's because I know we have to end up close to 2. Can't be close to 2 without being positive. Okay. All right, so we're going to be positive, and then I've got to either go up towards infinity or down towards negative infinity. If I went down towards negative infinity, I'd have to cross the x-axis. I know we don't do that. So it's going to look something like this. Now, I've here started above the asymptote so that we're not crossing it. That's because that's the simplest thing that we could have. If I wanted to start close to the asymptote and cross it, I'd have to sort of come down and then up like so. Now that can happen with some functions, but it's fairly unlikely when you've got a relatively simple formula like that. Generally, you're going to have less curve to stuff the lower the powers are. Okay, so I'm sort of making an educated guess here. I didn't ask you in this case to check to see whether we crossed the asymptote or not. We can actually review that just because it's good practice. But if I don't ask you to check that you're crossing the asymptote, it's a pretty safe bet that you're not. Okay, if you are crossing it, I will probably ask you to find out where. Okay, so let's see. Now, between -3 and 2, are we positive or negative? Well, we're negative because we know we're negative at this this y-intercept. So we're going to have to start big and negative. We come through this point, we come through that point, and then we've got to approach that horizontal asymptote. So my graph is going to look something like that. Okay. All right, again, I didn't ask you to check to see whether we do touch that asymptote, but let's go ahead and check that just for some additional practice. Okay, so 2x minus 4 over x plus 3. If we were going to touch that asymptote, that would have to equal 2 at some point. The way I'd solve this is I'd multiply both sides by x plus 3 to get that out of the denominator. So then I'd have 2x minus 4 equals, I'm going to just distribute, 2x plus 6, with the restriction that x isn't -3. That's not a legitimate solution because that would make the denominator 0. But now if I subtract 2x from both sides, -4 equals 6. Nope, no solution. So that does confirm that we do not touch this asymptote for this particular graph.